Hello and welcome to Dr. Jim's Structures class, where we do structures by example. Thanks for tuning in.
Man's practicing fuzzy math again.
This is the fifth video on example 1 from Dr. Jim's course on bending and beams and frames. Dr. Jim uses the computer program LinPro to analyze two-dimensional beams and frames. This video gives an introduction to LinPro's graphical input capabilities. LinPro is free, lightweight, graphical and easy to use. Dr. Jim recommends downloading a copy of LinPro for Windows from the web. Alternatively, get yourself over to Dr. Jim's website at drjimsstructures.com and download a copy from there. There's a link to Dr. Jim's website in the description. LinPro opens showing a 15 by 10 structural grid. The grey area of the screen is known as the working area. The previous video in the series provided an easy-paced introduction to using LinPro by analysing this two-span simply supported beam. The structural model was built using keyboard input, entered via 4 dialog boxes accessed by 4 buttons below the main menu. There's the coordinates or nodes dialog box. There's the members or elements dialog box. There's the loads dialog box. And finally, there's the cross sections or member properties dialog box. You might want to watch that video before finishing this one. If so, click the link on the screen. We are going to build the structure below using LinPro's graphical input capabilities. So let's get to it. First, choose the units to be used. LinPro offers 4 choices for units. Kilonewton meters, the default, will be used. Next, set up the structural grid. A 14 by 2 meter grid will be used and the beam will be built at a height of 1 meter. Note, the height does not matter. Now LinPro uses 4 pointer types for graphical input. These pointers can be selected by clicking the 4 buttons to the top left of the working area. The top button, the select pointer, is used to select nodes and members, and here's what happens when the mouse is clicked in the working area. This is a pet peeve of Dr. Jim. He thinks it's like having a piece of paper stuck to his shoe. What's happened is the click has established one corner of a selection marquee. To complete the marquee, click the mouse again. Most software packages require dragging the mouse to establish a marquee. That doesn't work in LinPro. LinPro is good, but it's not perfect. In fact, Dr. Jim recommends that for the sake of your mental health, you only click when using LinPro. Never drag. And don't ask Dr. Jim why it's called a marquee. He hasn't a clue. Clicking the Create Joint and Working Area button selects the pointer used to create nodes. Add nodes 0 to 3 to represent points A to D on the structure by clicking in the working area. Note the dynamic display of pointer coordinates shown at the bottom left-hand corner of the LinPro window. This is useful. It shows where the node will be created. We've seen how different input pointers are selected via the buttons to the top left of the working area. But there is a better way. Simply right-click in the working area to change the pointer. Another top tip from Dr. Jim. You're welcome. So, right-click and select Member from the pop-up menu. Click on Node 0 to start a member connected to Node 0. Now click on Node 1 to define a structural element between nodes 0 and 1. Notice LinPro now wants to add another element, this time connected to node 1. This is fine, so create a member between nodes 1 and 2, and again LinPro has started adding another element, this time starting at node 2, so click on node 3 to complete defining the beam. But wait, we're not done. There's a piece of elastic connected to node 3. Surely clicking the mouse will get rid of it. No it doesn't. To right click to open the pop-up menu, then make a selection, any selection, and doing that gets rid of that pesky piece of elastic. Notice Dr. Jim has selected the move joint pointer. Say node 3 needs to be moved up 1 meter. Clicking on the node selects the node, but dragging doesn't work. But I think we know that already. LinPro and dragging just don't get along. To move a node, first select the move joint pointer, then click the node to be moved to select it, and finally click the point it's to be moved to. Okay, we get the idea. Time to undo the damage done. But undo, Ctrl Z on the keyboard, does not work because LinPro has no undo capability. The damage has to be undone using the move joint pointer. LinPro is good, but it's not perfect. Next, add the support at A by right-clicking node 0 and selecting Pin Support. Note the options that appear in the pop-up menu depend upon what's right-clicked. Next, right-click node 2 and select Vertical Support. Notice that Node Not remains selected when node 2 was right-clicked. So when Vertical Support was selected from the pop-up menu, the support condition was applied to both nodes. The structure you now see is no longer stable. It's a mechanism. Effectively, it's been turned into a shopping trolley. To proceed, right-click and select Clear All. Next, right-click node 0 and select Pin Support. The structure is again stable. The lesson here is that you have to pay attention to what's selected when graphically inputting data. Now to loads. There's no way to define an inclined load in LinPro, so the 50 kN load at node 1 must be split into its components before it can be applied. The horizontal component is 30 kilonewtons and the vertical component is 40 kilonewtons. First add the 30 kilonewton horizontal component. Right-click node 1 to open the pop-up menu. The Add Load option looks promising, but notice Node Not is still selected, so adding a load would add the load to both nodes, and that's not what we want. And there's no clear selection option, so select the selection pointer and double-click in the working area to clear the current selection. The double-click defines a tiny marquee, and LinPro attempts to select whatever is in the tiny marquee. If there's nothing, the current selection will be cleared. And if a structural component is double-clicked, the current selection will clear and the double-click component will be selected. Another top tip from Dr. Jim. We can now safely apply the 30 kilonewton load. So right-click node 1 and select Add Load. Note that point loads can be applied using global or local coordinates. Clicking the hint button gives more information about the two systems. You might find it helpful to think of global as a coordinate system based on the structural axes, and local as a coordinate system based on the element axes. Either system can be used here because both the global and the local axes point in the same directions. Define and apply the 30 kilonewton horizontal component. And notice that Dr. Jim likes to use meaningful load names, and he thinks that you should too. His name system is based on the load magnitude and direction. So 30 units of load in the positive x direction is named 30x. Now do the same for the vertical component. The load is acting in the wrong direction. The actual load acts in the negative y direction, so it should have a negative value. And the only way to fix this is to open the Loads dialog box. It's a nodal load, so click the Node tab and select Node 1. Next, select and deassign the 40y load. Then define a minus 40y load and assign it to Node 1. Job done. But hey, not so fast. Look at that 40 kilonewton force. It's showing acting downwards, that's good. That's the direction in which it acts, but it has a negative sign. That's not so good. Logically, minus 40 kilonewtons acting downwards is the same as plus 40 kilonewtons acting upwards. What you need to know is that LinPro always shows forces in the direction in which they act. Dr. Jim's advice is to ignore any negative signs on graphical representations of loads and reactions. LinPro is good, but it's not perfect. Now, complete the loading by adding the 25 kilonewton force at node 3. The model is now complete, so click the green arrow to run a static analysis. It's super quick and the display changes to show the deflected shape. Clicking the M button shows the bending moment diagram. Clicking the T button shows the shear force diagram. Clicking the N button shows the axial force diagram. And clicking the R button shows the reactions. These all agree with our hand calculations from previous videos in the series. The white button to the left of the green analysis arrow shows the structural layout. The button to the right of the green analysis arrow gives access to tabular results. And the delta button shows the deflections. Now, close LinPro, noting that a save to file option is offered. This video has covered the key features of graphical input when using LinPro, but there's plenty more to learn, so keep on exploring. Well, thanks for watching. If you found this video useful, please give it a like and feel free to comment. LinPro isn't perfect, and neither is Dr. Jim. He's always looking to improve. Your feedback is appreciated. So, bye for now. Hope to see you again soon.
Phony numbers.
If I could respond to that.
Let me just tell you what the facts are.